In this video, we're going to take formulas and we're actually going to give the correct name. And it's kind of like the backwards process of the crisscross method, because you do need to verify where, for example, it says use the stock system unless otherwise directed. Now in this video, we're just going to focus on things that would relate to normal oxidation numbers, crisscross method, and the stock system. Again, the stock system relates to Roman numerals. And so if you have multiple oxidation states in your reference table or on table E, then what's going to happen is you need to label which one that is. Now, table E, of course, only has one charge to it for any of the specific polyatomics. But on the periodic table, as a reminder, as I flip to the periodic table here, I was on table E. And you can bear with me for 1 second. If you remember, in some cases, so let's pick iron, for example. Iron, +2 and +3. Manganese has multiple, +2, +3, +4, +7. And so the transition elements have multiple oxidation values. And so if we're in the stock system, or if we're in the lab and we want to say something like, okay, give me the iron oxide, the question is it iron 2 oxide or iron 3 oxide? Is it iron 2 chloride, iron 3 chloride? They'll have slightly different properties, so we need to make sure we're using the correct one, because that could mess up our lab. So when we're going through, and in this activity, I have some examples of polyatomics and regular binary ones, just with 2 elements. So we'll do a example, or a few examples for each. What we're going to do is we're actually going to look at the real element name. So you may need to use, if you're using the New York State reference table, table S has the names of all the elements, at least most of the elements, not all of them, but it has the symbols and the names of most of the elements in your first, the second and third column there. So Na, of course, is sodium, and O is oxygen. But we need to remember, when you name most materials, the second word is going to change. The first word, or the first element, is always going to stay the same. It's the second one that changes. Instead of ending in like INE for like all the halogens, like fluorine, chlorine, bromine, they're going to end in IDE. Other letters will change to that as well. So it's not just about the INE endings, but it's pretty much all of the nonmetals will change to an IDE ending. So this becomes sodium oxide. And what we have to do is we have to just check and verify that there's nothing else for the stock system. So just go back and you verify sodium only had a +1, oxygen was a -2. So if you remember your stock system video, or you can reference the previous video, sodium was +1, oxygen was -2. If I crisscross those, that's how we got this formula, Na2O1, because those original. So there was nothing else to play around with, okay? If we look at magnesium fluoride, again, look at my oxidation numbers. Fluorine is -1, magnesium is +2. So again, the first element is going to stay the same, magnesium, and then fluoride. Fluorine becomes fluoride. Jumping down, let's jump down to this one, Fe3S2. Now, not always are you going to see every single oxidation number. Now, if we look at this, for example, we see -2, then we see +4 and +6. Just because we see some oxidation numbers doesn't mean they're not all the possibilities that could happen or could potentially happen. So when we look at this, we know from previous examples, and I just talked about it in the beginning here, iron has multiple options, +2 and +3. So in order for sulfur to have gotten a 2, if we do the reverse crisscross and I go backwards with my arrows, the 3 must have come -3, and this must have been +2. So this must have come from an iron 2. So in this case, iron, Roman numeral 2, Roman numeral 2, and then sulfur is sulfide. Sulfur is from sulfide, okay? Lead, notice PbCl4. When we go and look up the lead, we looked at lead earlier in one of the other videos. Make sure it's on my video. +2 and +4 is options. Chlorine, pretty much we're dealing with the top one. If we go back, if there's no number, it's basically coming from a 1. This must have come from a 4. So lead, and then Roman numeral 4, IV is Roman numeral 4, and then this would be chloride. Now, if we look at calcium sulfate, now I have multiple elements. I may need to go back and use table E. So Ca, if we look up calcium, calcium over here has a +2 charge on it. So calcium's +2. If we flip back to table E, anytime you see more than 2 elements, assume you have a polyatomic. And you know you have more than 2 elements if I have more than 2 capital letters. Remember, every capital letter starts a new element. If it's a lowercase letter like the A here, that means it's the same element that belongs to the C. But the O is a capital letter, so that's a new element in addition to the O. So we're looking for SO4. And when we look up SO4, SO4 is right there. It has a -2 charge. So calcium was +2, sulfate was -2. They eliminate each out, and basically we just take the name calcium and then sulfate. Now, it's likely very easy just to look through and name them and then forget to put the oxidation numbers or the actual stock numbers. So for example, if I look at this, don't call this potassium nitrogen oxide. Okay, potassium nitrogen oxide is not the correct thing. Again, if I see 3 elements, that means I need to look up on the table E. So we want to look up NO2. Usually the first letter is good by itself, and then the second 2 would be the nonmetal group or the negative group, and this was NO3, which is nitrate. Don't confuse that with nitrite. So NO3 is nitrate. Oh, and excuse me, I just did. So it's a good thing we went back and looked at it. I was in my head thinking nitrate, NO3, but really we're using NO2, and again, I'll zoom in on that. NO2 is nitrite, so we want to make sure we label it correctly. Just by labeling by one letter means you have a different chemical, which means different properties, therefore it's wrong. So this is potassium nitrite. I want to make sure I have an I here and not an A. And so if we go through, I don't see any more examples here, but I could see, for example, I'm going to put up, let's see, we'll do this one. I'm going to do this one on the side, just draw a line here. And we're going to do hydronium, which I just did that backwards. Apologize for the shakiness based on my setup. I'm in the back of a chem lab using basically a ring stand setup for my video on my phone. So I'm going to do this backwards, but I just kind of gave you a hint. So we're going to go H3O 4, oops, sorry, H3O 3, PO4. And I'm just going to put them both in parentheses for now. I didn't need to put this one in parentheses because, of course, it did not need a parenthesis because I didn't change the number, but there is a 3 here because the phosphate does come from that. So H3O, notice I have 1 capital, 2 capitals, 3 capitals, 4 capitals. That's 4 different elements. That's a good indicator that you have 2 polyatomics. H3O is the hydronium ion, and PO4 is the phosphate ion. So we end up with hydronium phosphate. So we're basically taking the names that we see here and we're keeping these. These names always stay the same. We don't change the endings of these. The only endings we change are of elements that are, nonmetals that become an IDE ending. So hopefully you found benefit in this, again, how to take the name or the formulas and turn them into names. In previous videos we took the names and created formulas. You should be able to go back and forth between each just using table E and using your reference table and your knowledge of chemistry.